Hello, geometry students. So today we are going to focus on arc length and area of a sector. And I know the the Desmos activity you did yesterday was focusing on introducing those two concepts. So today we're going to practice a little bit more in depth with them. So as a review, so we're still talking about circles here. Area of a circle, remember, is pi r squared. Okay, so here's an example of a circle in the middle here. So if I open the flap here, if I want to find the area of the circle, so again, area is pi r squared. And if I look at the picture, what's the radius? Hopefully you notice the radius here is 5 inches. So if I take pi times 5 squared, that's going to be 25 pi, and then my units again would be square inches. So again, that should be a review from our area units. Also a review is circumference of a circle. So remember, circumference is 2 pi r, or pi times diameter, whichever you prefer. So if I flip it open to the inside piece here, again, my radius is 8 centimeters in this case. So circumference is 2 pi r. If I take 2 pi times the radius, which is 8, 2 times 8 is 16, so my answer is going to be 16 pi centimeters. Now, the focus for area of a sector and arc length. You don't want the full circle. So when we're talking about area of a sector of a circle, it deals with area of a circle, but again, I don't want the whole circle. I just want a piece of it. Okay, so if I flip it open to the inside for a minute, if I want an area of the sector, I just want this section here. I don't want the full circle. You're not going to eat the whole pizza or the whole pie. Okay, you want a piece of it. You want a, like it says in the middle, you want a fraction of it. Not the whole thing, but a fraction. So the formula that we use for area of a sector of a circle, we're going to put whatever the arc is over 360, because again, 360 is a full circle degree-wise. And we're going to multiply that fraction by the area of a circle, which is pi r squared. So again, you want a fraction of the area. So to find your fraction, you're going to put whatever your arc, or for that matter, your central angle is, over 360, and multiply it by the area of the circle, which is pi r squared. So if we do the example here, okay, now my arc is also going to be 60 degrees because my central angle is 60. Those are the same. So to find the area of sector, in this case CAB, I'm going to put my arc, which is 60, over 360. I always put it over 360 because, again, a full circle is 360 degrees. I'm going to multiply that by pi r squared, and my radius in this picture it shows is 5, or 5 inches. So if I look at 60 over 360, that reduces to 1/6 of 5 squared is 25, so that would be 25 pi. Now if I'm going to solve this, I'm going to put 25 pi over 1, because anything over 1 is itself. And then I'm going to multiply across the top and across the bottom. So across the top, 1 times 25 pi is 25 pi. And on the bottom, 6 times 1 is 6. So my answer is going to be 25 pi over 6. And its area, so it's square units. So we're going to have square inches. So again, I don't want the area of the whole circle. I just want the area of a piece of the circle. Okay, so last but not least, if we talk about arc length, that refers back to a fraction of the circumference of the circle. So it's just like eating the crust off the pizza. You don't want the whole thing, you just want the crust. So in this situation, I just want, again, the crust of this piece. Okay, not the whole thing, just the crust. So it's a fraction of the circumference. So again, we're going to put the arc, whatever it is, over 360, and multiply it by circumference, which we had just talked about. The formula for circumference is 2 pi r. So again, whatever the arc is, over 360 times 2 pi r. So if we do our example on the inside here, if I want the arc of this piece, not the whole circle, I just want the crust off this piece. So we're going to put our arc, which remember is the same as the central angle. So that's going to be 45 degrees. So I'm going to put 45 over 360 and multiply it by circumference, which is 2 pi r, and it shows my radius is 8. Okay, so if I think about it, 45 over 360 can reduce. Okay, that's going to be 1/8. And again, 2 pi times 8, well, 2 times 8 is 16, so it's 16 pi. And again, I'm going to put that over 1. If I multiply across the top, I'm going to have 16 pi. If I multiply across the bottom, I get 8. And then 8 can go into 16. This can reduce a little bit. 16 over 8 is 2. So my answer is going to be 2 pi centimeters. So something to take in consideration. If you're doing an assignment and it asks for an approximated answer, then you're going to actually have to take your calculator and multiply 2 times pi and then round appropriately. Or in the previous problem, if it's 25 pi over 6 and they asked for maybe an answer rounded to the nearest hundredth, you're going to actually have to take your calculator and take 25 times pi and then hit divided by 6 and again round appropriately. Okay? If you have any questions, please let me know.